start sharing my screen. So before we go to the session, you have to guess. Let me. I'll share my sound. So what does it mean? Sinkara. Okay, good. Water. Good. Izaz is writing water. Haritha is also writing water. Okay, so maybe the newer generation, you must maybe not have seen this ad, but this used to be a very famous ad when we were having the childhood. Many of the participants, they have answered also Sinkara. So it was like a Ashutosh has written. Yes, let me see. Okay, so Sinkara, that used to be a tonic, like health tonic maybe, and that was the ad of a health tonic, which gives energy, and this ad was for that. So maybe now we need to have more ads or more content related to this newer generation. Okay, so we'll try from the next session so that everybody could answer and could see and understand. Oh yes, Severe Seeker is writing. Hridaynath is writing, yes. True. I was also thinking on the same line. So we'll have now something more Korean and anime and those things to have a good discussion here on this fun activity. So coming to the concept of relative risk. Relative risk is also known as the risk ratio or a rate ratio, and it is alternatively called as a relative rate. It measures the strength of association. And this also, actually, you all know from your previous knowledge that generally it is calculated in the incidence type of study and in a cohort study or a follow-up study. So you start with a population, exposed versus non-exposed, and then you see the outcome. So you see the risk of disease in the exposed versus risk of disease in non-exposed. So types of study design where we can use this relative risk. Most commonly, it is done in the prospective cohort study, but we can use this in retrospective cohort also, or in the combination of the two type of study. So how do we interpret relative risk? So if the value of relative risk is 1, then we say that there is no association. That means the exposed versus non-exposed, there is no association between the risk factor and the outcome. If the relative risk is more than 1, then we say that there is positive association, which means that the risk is more, the outcome is more in the person who have got that risk factor as compared to the people who doesn't have the risk factor. And if it is less than 1, then we say that it is protective association. That means the outcome is less in people who have got that particular factor. And in that case, we don't call it as a risk factor because the relative risk is less than 1. So there are some underlying assumptions, like the underlying assumptions we have tested for the chi-square. For relative risk also, there are some underlying assumptions. So the first assumption is that it should be a dichotomous variable. So all these relative risk and odds ratio, it is applicable only in 2x2 table through this option. If you use the logistic regression, then in case of odds ratio, you can get odds ratio if it is more than 2x2 table. But through this option of contingency table, you can get odds ratio and relative risk only when it is a 2x2 table. So there it should be a dichotomous variable, one dichotomous dependent variable, and the other dichotomous independent variable. The second assumption is that it should be independence of observation. We have discussed this concept. And the third is like it is applicable for like we have done prospective or a retrospective cohort or a randomized control trial. There's another concept which is the odds ratio. So underlying assumptions of odds ratio is that, again, it should be one dependent variable which is a dichotomous, the another independent variable which is again a dichotomous variable. There should be independence of observation, and it is applicable for case control study and analytical type of cross-sectional study. So the underlying assumptions are almost same for both these study design, both these type of risk measurement. The interpretation of odds ratio is, if the odds ratio is 1, the odds of exposure is same for the cases and control. And in that case, we can say that there is no association between the disease and the associated factor. If the odds ratio is more than 1, we say that the odds of exposure among cases is greater than among controls. That means there is positive association between the disease and the associated factors. And if it is less than 1, then we say that the odds of exposure is, in cases, it is less than among the controls. So this is the interpretation of odds ratio. Now coming to the question. So if you see the question which I have to demonstrate, that is the, like, I want to determine whether smoking status has got any association with oxygen requirement at admission, and if it is associated, then what is the type amount of this association. So this we have done in the case of first case also, where we have done the association and phi and Kramer V. But if you want to tell the, in context of a odds ratio, how high or how low, in that case, you can calculate the risk also. Although this option of risk, we very less often we use it. Why? Because this is an unadjusted odds ratio. And most of the time, we use the adjusted odds ratio. And how can we get the adjusted odds ratio? There are two types of odds ratio. Unadjusted odds ratio is odds ratio when you take only one variable as a predictor variable and there is one outcome variable. In case of a adjusted odds ratio, you have got one dependent variable, but you have got many independent variable. So actually, naturally, you cannot have an unadjusted odds ratio because you will not study anything in controlled environment. An individual will have an influence of many other variables also. That's why this option, although we are telling you because it is there, but excuse me, to calculate odds ratio, unadjusted or adjusted, it is better that we go through the logistic regression option, because there you can get odds ratio even if it has got a 3 categories. Like if you want to have an odds ratio between mild, moderate, severe, you cannot do it using this contingency table option. But this is also one option. That's why we are telling you. So this is, again, what I will do. I'll go to the Jamovi. And in this case, what I will move the, so smoking and oxygen requirement. And the question is, again, I have to read the question. I have to see that the smoking status has any association with the oxygen requirement. So oxygen requirement is my dependent variable. So I'll move this oxygen requirement to this smoker to the row and oxygen requirement to the column. And in that case, now I will not tick any of these options. I will use this odds ratio. And if I click odds ratio, you can see the value of odds is here. The value of odds ratio is 0.461 with the upper and lower boundary of 0.211 and 1.01. So what it says, that this is not significant, because if your odds ratio has got value of 1 in between, then we can say that this odds ratio all the this this is not significant, but now we have to interpret it. So what will be the interpretation of this 0.461? So this 0.461 tells you the odds in this cell. If you focus, this says the odds in the smoker. So it tells you that this oxygen requirement, because that is the dependent variable. So the odds of oxygen requirement in smoker is 0.46 as compared to the odds of oxygen requirement in non-smoker. So you have to see the reference level here. If you go and see in logistic regression, it tells you the reference category also, in what reference it is telling you. But if you use this option, it doesn't tell you the reference category. That's why you have to interpret it that this tells you the odds in this cell, this one. So it tells you the odds. If you calculate this, it will come. So it tells the odds of oxygen requirement in smoker. So odds of oxygen requirement is 0.46 in smoker as compared to the odds of oxygen in non-smoker. That's how that means it is less. That means oxygen requirement is less in smoker as compared to non-smoker. Now coming to this is the interpretation of this odds ratio. Coming to you will again have a session on odds ratio in the logistic regression, and there you will have more clarification on the reference level, which you may get confused here. But till now, you just remember that it tells you the odds ratio of this cell, which I have shown. Now coming to the relative risk, because it is in the same window, this option. If you see this relative risk, so the question is, if I want to determine whether the use of steroid at the time of admission has any effect on the outcome. So it is a prospective type of study because I have given the steroid and now I want to see the outcome. So in this case, the independent variable is the steroid and the dependent variable is the outcome. So what I'll do, you go to the Jamovi, outcome is the dependent. So that I will move to the column. So I have moved to this column, and then steroid is the independent variable. So steroid 1 is the independent variable. And then I have clicked the relative risk. So you can see here the value of relative risk is 0.865. So this is again the relative risk in this cell. So this tells you that the risk of, if you go up, I will again, because that is not visible. Yes. So what do we mean by this 0.855? So this 0.855 says that the people, odds of the steroid, application of steroid in people who have died, it is 0.865. But again, when I am saying this, it is not making any sense to me. So what I'll do, so I want to see that in people whom have I given the steroid, what was the odds of the outcome? So this is again, we can say that the odds of death, it was more, it was 0.85 in the people whom we have given the steroid at the time of admission. That means it is less. If it is 0.85, you can say that the steroid is protective for death. And that's how the odds. And similar, you will see that the people whom we have given not given the steroid, the death is 18.6%. Whereas in whom we have given the steroid, the death is 4.8%. So this is how we do the interpretation of relative risk. So it is same for both relative risk and odds ratio, the category. That means it tells you the relative risk or odds ratio of this cell. That means in death, percentage death, and you have to take this yes. So that's how you have to interpret it. Is it okay for all of you? Yes, so what happens if upper or lower more than 1? So then that means you will see in the logistic regression that it is not significant. If upper or lower is more than 1, means you want to say that confidence interval is having the value of 1 or what? Hriday? Can you clarify? CI. Oh, yes. So that's how here you can see that the CI is less than 1. That means it is not having the value of 1. So if the confidence interval is not having the value of 1, that means it is significant. If it is having a value of 1 in between, that means it is not significant. Any other question before we go to the breakout room?
Ma'am, I want to ask one thing.
Yes, Rupali?
Is it relative risk? Can we take it the number of times it is like more risky? Like it's less than 1. So can we take it in a beneficial way?
Yes, you can do that. You can do that. We will do more regarding this in logistic regression, but again, you can express it in the form of percentages. Yes. So you can do it like 100 minus 85. So yes, 15%. So if you want to express it in the percentages, both odds ratio and relative risk, you can do like 1 minus the relative risk or odds ratio multiplied by 100. So that much percentage higher or lower will be the value. True.
Right. Thank you.
I should have told that. I'm sorry, Rupa, and thank you, Rupali, for reminding, because this is again one way of interpreting, but we will discuss more about these things in logistic. That's why maybe I was like, being lazy, but thank you.
Thank you.